Okay, so now let's ask a different type of question. Based on this short sample of annual returns you have, what is your expected annual return for the future? Well, of course, we don't know the future, but what if we could come up with likely scenarios for the economy and attach probabilities to them, right? So if we knew the probabilities and if we knew the possible outcomes, then we could calculate the expected future annual return as the probability-weighted average of the possible outcomes. All right, so in this table, what you see is our 4 possible outcomes, 4 possible future states for the economy, right? The table shows that the market could be in an excellent state with 25% probability. It could be in a good state with 45% probability, in a poor state with 25% probability, and it could crash with 5% probability, right? Also, you see the return outcomes for an investment of $100 in each state with the probabilities associated, right? So given these possible return outcomes and the probabilities associated with each state, we can compute the expected return as the probability-weighted average of the possible outcomes, right? So how do we do that? Well, the expected return is going to be the probability of the economy being in an excellent state times the return of on our investment in that state, plus the probability of the economy being in a good state times the return in that state, right? Plus the economy being in a poor state times the return you get in that state. And finally, the probability of having a crash times the return in that state, right? So if you sum these all up, you're going to find the expected return given the possible outcomes and the probabilities, right? Obviously, this is a Mickey Mouse example, but suppose we had M outcomes, right, with probability Pj for each outcome, right? What is the expected return? Well, it's going to be j going 1 to m, Pj times Rj. So in general, the expected return is the probability-weighted average of the outcomes times the probabilities. Okay, now let's go back to the short time series of annual returns we had. Remember, we had 5 years of past returns. Now, how can we find the expected return looking at this past 5 years returns? Well, we could treat each observation as an equally likely possible outcome, right? We can find the expected return by assuming that each return that we had was equally likely, right? So we can substitute for this probability 1 over 5 or 1 over n if we had more observations. So the expected return we would compute would be, right, basically 1 over 5 for this 5 years, the return on the first year, the return on the second year, the return on the third year, right? The probability-weighted average of the annual returns, where the probability is now equally likely, right? Well, this is actually the arithmetic mean. What is the arithmetic mean? All right, the arithmetic mean, let me call that with R bar, is simply, if we had t observations, it's 1 over t times R1 plus R2, and so on and so forth, all the way to RT. Right? So the arithmetic mean gives us an unbiased forecast of the expected return. So in this lecture, you learned how to compute the rate of return for any given period for an asset. You also learned how to compute the geometric mean and the arithmetic mean, and how you can use them. See you next time.